Yeah, hi there, and welcome to this little session on the assignment brief, the 308 assignment brief. So that's the assignment for the electrical maintenance for food and drink operations. Okay, I'm trying to keep it short and sweet, so bear with me. Okay, to start off, we've got obviously you've got the assignment brief, and please take some time to read through it. Don't just go for it when you do the write up, but read through it yourself. I'm just going to quickly coach you through what you need to do. So these are the four things, the four tasks you have to do, and you can do this at work, or if there's no opportunity at work, we will do this at the PMC when you come back. The first one is the three-phase motor system, which again, all it is just a maintenance task. So you don't have to take it off, do some fault finding or anything like that. It's just a maintenance task. So that means so, for example, you could check the resistance of the coils, and make sure that the coils are okay, for the three-phase motor, or you can do an insulation test if you've got the equipment at work, which I'm sure you will have. So that's a high voltage test on the coils against earth. You can just make sure that the terminals are, tight, that they are properly connected. Um, just check for dirt. That's okay as well. So if you open it up, make sure the terminals are free of dirt and there's no dust or dirt in them. There's no liquid that seeped into them or anything like that. Yeah. So that could be a general maintenance task. If you work with your mentor or who's coaching you at work, and providing it's a task which is on a three-phase motor, that's fine. I'm okay with that. A DC power supply system, you will find this most likely in cabinets. You can take a power supply system externally. So if you've got one in the stores and you just want to check it out, you need to connect it to obviously 240 volts. Have it done by a competent person. All I need you to do is just check that the output is 24 volts, and you can tune them in as well. So most of these power supplies have got a small screw somewhere. It's like a tiny, tiny screw, and that operates. I think it's a potentiometer inside. But anyway, you can with them you can adjust the voltage slightly, so you can put it up a bit or put it down a bit, depending on what the output is. So it allows you to tune in the power supplies. If you do something like that, that would be more than enough. Just measure the voltage, make sure it's 24 volts, and also tell me what you would do if it isn't 24 volts. If it's too high, maybe it's 25 volts, or if it's too low, it's 23 volts, and you want to put it spot on to 24. How you would do this, and get some photographic evidence as well. Single phase system, anything goes here. So it can be a luminaire, yeah, lighting system. It can be a single phase motor. Um, Maybe I mean sometimes for hand tools you've got these yellow boxes or transformers. Can be one of those. Yeah. If you have one of those, you can just do a portable appliance test or something. That would be maintenance. Maintenance test would also be if it's a single phase system, to just check that the wiring is okay, that everything is fine. Make sure that the terminals are tight, that everything is okay, and that's it. So it just needs to be a single phase system as opposed to a three phase system. So it could be a motor, could be a light fitting, could be one of these transformers you use for hand tools, possibly even those hand tools as well. If you do a portable appliance test, that's pretty much maintenance task really on them, where you do a little bit of an insulation test, even though it's only 110 volts. But you can comment this in your write up and tell me what it is and how it all works together. Uh, right, then we've got a PLC control unit. So I don't want you to do any programming. That's not necessary. But you can tell me how you would take the program off a PLC without having to do it, and how you would upload the program if a PLC was ever to go down. A simple maintenance task can be is just to make sure that all the terminals, all the wires are properly connected, that they are tight, in the terminals, that the sensors are working. So when you look at the inputs and outputs, you normally see little lights coming on and off, and you can just maybe run a couple of checks and make sure that they are working. And that's all. That's all that's required for this. it says here for each type of system you must carry out a maintenance check, yeah, and that's really the must. That's what you have to do, and replace any defective, damaged, or out of spec components. Yeah, so if there aren't any components which are defective, there are no damaged components, or there are no out of spec components, you don't have to replace them. As simple as that. If something is damaged and it fits in with the job you're doing anyway at work, then fine. Comment on this as well, and write a little bit about what you have done. So the activities can be carried out at your workplace, and as I said before, if you can't do it at work or you don't get everything done, when you come back to PMC, whatever's missing, we'll catch up with that. So I need evidence of you planning the activity, carrying out the maintenance activity, and ensuring the effective handover. So there's 3 stages which I need for each activity. So that's the planning, the doing, and the handing over. Okay, we've got a little bit about the planning. Yeah. Details of inspection, testing methods, problems or faults. So talk about the stuff you expect might go wrong with the equipment and what you're testing for. Yeah. So for example, if you're testing for loose terminals, you could say that vibration of the motor might loosen screws, and if you get like loose screws, you get like sparks and arcs, and it's not a good thing. You get the contacts being affected by it over time, and you could talk about that if you wanted to. Right. Give me details of your engineering information. That feeds into the merit as well. Anything you can come up with. We're going to look at the merit and distinction criteria separately in a moment, but again, read about this. Yeah. I need a risk assessment, which is very important. I need a method statement, and yeah, that's it. So we've got then this section here, which is just the theory section, and you're supposed to cover a little bit more on your 3-phase motor. So you've got your job write-up. Yeah. So you start off with this is what I'm maintaining. This is a communication allowing me to do the work. This is a method statement. This is what I'm going to do. I'm going to lock this off and tuck this off, and then I'm going to use XYZ tools. Then I'm going to go to the equipment. I'm going to check this and that. Then I'm going to put it all back together. Remove the log off, tug off, and recommission the line and do an appropriate handover, so that the engineer in charge knows everything is back on track. Right, what else have we got? We've got the 3-phase motor. Let's go quickly through that one. So look at different types of 3-phase motors. So you've got asynchronous and synchronous 3-phase motors. Again, it's just your notes from class. Just use them and write them up in your own words about these 2 systems. Then explain a little bit about earthing systems. Maybe you can find some earthing system, some earthing on the 3-phase motor. Maybe you see some earth connections on the line, which goes from possibly the motor, where you've got an earth strap going to somewhere else on the line. Document that and then tell me why this is necessary and why is this good to have this. Then explain the supply system arrangements for the equipment you're maintaining, from load itself to the point of generation, defining system voltages at each stage. Again, when you look at this statement here, you can interpret this in 2 different ways. One of them is just, the plant itself. Where does the power come from? So you will have a substation at the plant somewhere, where the power comes in at most likely 11 kV, or I think it's 11 kV. Just check it out, maybe ask about it, and then, talk about where the power comes from, document it as much as you can. Or you can have a very global approach, which we did in class as well, where you look at, where's the power generated, like at the power station. So you've got a turbine, the turbine goes around, driven by steam. Then the turbine will generate, I'm not sure, I have to remember, I'm just doing this out of the top of my mind. At X amount voltage, I think it's 32 kV. Then it is transformed to 400 kV, moved across the power lines, comes up to a substation near you. It's transformed down, then it's transformed down again, and then it ends up at your factory at a lower voltage, and then eventually it goes, to 3-phase current, as at 240 or 415 volts, which drives your motor. So you can go all the stages. Just make sure. I mean, I'm not gonna grossly penalize you or whatever, but a little bit of advice is when you research this on Google, they will come up with diagrams for American systems and for European systems. Now, European systems and American systems for power generation are slightly different, so just bear this in mind. Not the end of the world, and I'm not going to penalize you or anything like that if you get the American one, but for me the main thing is just the concept, that you understand that power is produced in three phases, and in America you find it's produced in two phases, so they're slightly different, and you get two-phase power. But here we produce power in three phases, and it's delivered all the way to the factory in three-phase power or current, and then it's fed all the way to your motor, through various methods of transforming it from a low voltage to a high voltage, back to a low voltage, and even a lower voltage. Then it comes up and turns up at your motor. Okay, we've got DC power supply. The DC power supply you're most likely come across is a 24-volt power supply. Just take it there. Normally these little blade type units which are in your cabinets at work. They're normally used for sensors and PLCs and the little stuff which is controlled by them. Possibly contactors, actuators as well. So have a look at them. Give me some beef on the DC power supply. Why do we need it? The answer is components which we drive, like ICs and discrete components like transistors and semiconductor devices. They all require fairly low voltages at DC levels or DC voltages, and they are the ones we're driving, and that's why we need this 24 volts DC, supplied in our cabinets for all sorts of stuff. Okay, DC circuit operation. Have a look at the power supply. You will get some ratings on there, so it'll tell you 24 volts, possibly 100 watts. Then you look at the formulas, just box standard Ohm's law. In this instance, it would be power divided by the voltage will give you the current. So the maximum current you can get from the power supply in this instance, if it's a 100 watt power supply, would be about 5 ampere and a little bit more. So about 5 amps. So you need, again, this is affecting your wires as well. You need to have wires if you have to carry all of the current, which are capable of carrying 5 ampere. Otherwise, the wires get hot and you get a big bit of a voltage drop as well because of the resistance in the wires if they are running across any length. So again, it's all stuff you can talk about in your assignment. Then we've got PLC control circuit. Okay, again, when you look at the stuff that's written up here, just have a look at the lesson, the presentation I did with you on PLCs, and just put the stuff down in your own words. Where does a PLC come from? Why do we use it? What is ladder logic? How does ladder logic work? Give me maybe an example of the latch, a latching switch, which we did in class. And that's all. That's all you need to do for that. And then we've got single phase system, explain the circuit connection configuration using a system and maintaining other types available. So talk about your live, neutral, and earth. Look at different types of cables you have found. What are they? Are they steel wired armor? What type of cables are they? What else can you write about it? Talk about the trunking, which we're using, the containment systems. That's the trunking. So where are the cables in there? Maybe just take some photos of whatever you're testing, and talk a little bit about it. That's all. And then lastly, describe the type of luminaires found in lighting circuits in food and drink operations. So all, again, I expect you to do here is your work in food and drink operations. Have a look at the ceiling and see what lighting systems have you got. Are they LED? Are they tungsten systems? Are they halogen bulbs? Or what is used? What do you use for the luminaires? Maybe fluorescent lights, whatever it is. Just try and write about this and maybe say as well, talk about the alternatives you have. And again, when we look at, in a minute, we're going to be looking at contingencies. So that's the kind of stuff I'm looking for as well. So look at contingencies at alternatives. So what lighting system have you got? What other lighting system could you have instead? And what will be the consequence? Would it be cheaper, more expensive, or, a different type of light or whatever? Okay, talk, bear always in mind safe working practices and food hygiene. So talk a little bit about that. Make sure you talk about the handover. I found in the past that a lot of people forgot about this bit here. No mentioning about the handover in future proving. Okay, let's have a quick look at merit and distinction. Again, what I'm looking for merit is that in your method statement there's some detail in there. You talk about contingencies, alternatives throughout your assignment of, if that doesn't work, what else could you use? What could go wrong? How could you make sure that you are catering for certain problems you may come across in your maintenance task? So that would be alternatives, like have another set of spanners, or make sure you've got spanners which allow you to go into very difficult to access areas, stuff like that. When you talk about alternatives as well, I mentioned before the lighting systems. Describe me what you have, and then talk to me about what else you could use. The same with trunking, or what cabling is used, what wiring is used for your single phase systems. What could you use instead? That's about contingencies and alternatives. That's what I'm looking for. Supporting engineering information for a three-phase motor, or if you use a single-phase motor, there are always little plugs on the motor. Just take a photo of them and tell me what all these little bits on the motor, what they mean. What's the relevance of all the information you get on this little plug that's on the three-phase motor. Or have a look on the internet and get all the data sheets and add them to your assignments. So again, that would push you into merit territory. Some explanation, proposed risk assessment. So if you do a risk assessment and you just say, this goes wrong, that could go wrong, that could go wrong, that could go wrong. This is what I'm going to do, this is what I'm going to do, this is what I'm going to do. That's pass. If you give me some explanation and you tell me why it could go wrong and what are you doing about it, that's merit territory. And to preempt it, so distinction would be you start prioritizing everything. You say this is the highest risk, that's the next highest risk, that's the next highest risk, and that's the lowest risk. So if you do this prioritization, you're in distinction territory. Obviously, there's a lot more to it as well. We're gonna look at that. Risk rating has some control. Okay, we did this. Some attempt to prioritize risk. We did this as well. Documentation completed accurate and clearly, so neat and tidy assignment. Feeds into merit territory. Calculations are accurate with partial methodology shown. So that's the calculation for the power supply. Presentation is clear with mostly accurate notation. Explanations are reasoned with relevance for the maintenance activity. So whatever you explain needs to, like your explanations later on, need to feed back to the ideally to the maintenance activity. Evidence shows a lack of consistency in approach and quality. A lack of consistency in approach of quality. So that means you've got good quality, but not all the way through. It's just to differentiate yourself from a distinction. Okay, let's have a look at the distinction. So you've got a totally detailed method statement. So there should be extensive references to contingencies that need to be considered an appropriate alternative. So we go more into the whole, more contingencies. How can you do this? What could go wrong? What other tools can you take? There are three-phase motors, but you could have different three-phase motors. What different luminaires are available, which could be used for the company. So it's a little bit more beef in that area where you look at alternatives for everything you talk about. But it's extensive. It's a lot of stuff. So that means there's a lot more volume if you want to go for a distinction. Extensive, valid supporting engineering information is used to support planning. Again, we see all these magic terms here, extensive. So I'm looking for lots of data sheets, for lots of engineering information about the motor. Proposed risk assessment control are clearly justified. So pretty much similar to before, but you've got a justification for it as well. And then you use historical data for your risk rating. If you can't get hold of it, just show me something that you're looking at, what has gone wrong in the past. And it could be anecdotal, or it could be, hardcore data. But I need to get this historical aspect of your risk assessment. You know, why are you doing this? So, for example, if you have to lift the motor, you lift the motor, you know, with a winch, because, and you can then look at historical data. When you go to the health and safety executive, and I think it's about 70% or 80% of injuries are back injuries, which are down to lifting. So there's a very high, and you can get this data. I don't know whether this is the correct data, so don't quote me on this. But if you go to the health and safety executive, you get like a lot of historical data of, you know, injuries which are likely and which happen, and just refer to that. So have some reference to that as well, and do this. So again, distinction is a lot of hard work. So if you want to go for it, prepare yourself to do some hard work for it. All risks are prioritized. Documentation completed, accurate and clearly presented. Handover documentation shows appropriate consideration for future planning. So this comes in here as well. I need some future planning here. So the next maintenance task should take place in 3 months' time because of X, Y, Z. Something like that. Calculations are accurate with detailed methodology shown. Presentation is clear with fully accurate notations. Explanations include clear, detailed reasoning, clearly linked to the maintenance activity. And then here we've got the last statement. Evidence is consistent in approach and quality. So you need to have the same quality. This is what it's saying here all the way through for all 4 tasks and all the explanations you give for the 4 tasks. So when you go for distinction, what basically will happen is, you know, you do your pass, and it's just very straightforward. For merit, you do your pass plus, and it's maybe not that much work. You just make sure you hit all these points somehow. And then when you go for distinction, you've got all these magic words like extensive. You get extensive here, extensive there, covering all maintenance aspects, risk assessment control measures clearly justified, historical data. All risks are prioritized, and future planning we've got here as well. Presentations accurate, okay, detailed reasoning. You know, all these words are here, which suggests there's a lot of bulk to it. So if you want to go for a distinction, just prepare yourself to work hard. Don't just have a pretty assignment, but make sure you hit these points here. In the end, what I'm going to do is measure your performance against criteria. I'm pretty straightforward on pass. I'm just going to show you the which you've got as well, I think. This is a grading matrix, which has to be. I mean, I'm not sure who signs it off. I think either your mentor can sign it off if you've done this. I would sign it off as well as far as assessing the assignment is, and then. And that's really all the points which you need to do is it's just make sure you've covered all these points somewhere in the assignment. Everything needs to be covered here. So, right. Okay, that's it. If you've got any questions, feel free to email me. I'll respond to your emails. I'm not sure whether you're affected by the lockdown and you have to self-isolate or what's happening. If you have time, it's probably the ideal time to do this. To do this assignment. For these practical tasks, just try and liaise with work. If you can't liaise with work and you can't do certain tasks, it's not a problem. You can do them with me. I need some evidence that somebody has seen you do this. It could be an email, it could just be a written statement on your assignment brief or something like that, from your mentor or colleague who is seeing you do the maintenance task. So I just need this signed off because I'm not there. I don't know whether you've done it. So there needs to be some, and again, the verifiers, the internal and external verifiers, need to have some sort of evidence as well that it's been done. So if I've seen you, obviously I can sign you off. But if I haven't, then I need somebody else. Ideally your mentor. For this bit here, again, it's just a box standard write-up. I would say that most of the notes you have taken in class will give you the brief for this write-up here, and just put it together. Try and relate it back to your work if you can, and to possibly the practical tasks if you've done them before. If you haven't done them, just keep it generic, make it general write-up, and that's all really. again, if you've got any questions, feel free to contact me. I've got more time now, so should be able to respond to you a lot faster than in the past. Okay, all the best. Talk to you soon.